Okay, so today we're looking at what is known as the modulus function. So it's called the modulus or absolute value of a real number, and you'll probably hear me also use the word magnitude as well. That's a word that's often used in physics, is magnitude. So the modulus or absolute value is more mathematical. Also in physics we use modulus. So the modulus of a real number is x is written as x with these two parallel lines. So what does it mean? It means, as it says there, we want the size, the number, how big it is. All right, so that's what we're looking for. How big is it? So, for example, the modulus or the absolute value of 3, how big is it? It's 3. That's how big it is. Modulus or absolute value of -4, how big is it? It's size 4. It's big. It's negative, but its size is 4. All right. So effectively, if there's any negatives there, we're ignoring negatives. All right. So that's it in its basic form. All right. So let's have a look at and evaluate some. So you just need to be aware to do things in order. So here we've got the modulus signs on the outside, and we've got -3 times 2. So here we do the -3 times 2 first, which is -6, and then the modulus, of course, is 6. Here with these ones, what we would do is we would do the modulus first, so that's 3 times 2, which is 6. All right, similar for parts C and D here. The first one here, you do the -4 divided by 2 first, which is -2, which then, of course, is 2. Or this one, you do the modulus of -4, which is 4, over 2, which is 2. So in both of those, with the multiplication and the division, it doesn't look like it makes any difference. Really, where those modulus are, you get the same. However, that's not always the case. So here we do the -6 plus 2 first, which is -4, and the modulus of that, of course, is 4. Over here, we do these things first before we do the addition. So the modulus of -6 is 6 plus 2, which is 8. And so that's different. Now, what I haven't done is I haven't done an example here where I'm subtracting. So say, for example, I go modulus of 8, take the modulus of 3. We do the moduluses first, which is 8, minus 3, which is 5. All right, whereas that would be different than if it was the modulus of 8 take 3. You'd do this first, -8 minus another 3 is -11, which of course then is 11. All right, so the one on the left here, it's just a normal, it's these absolute value modulus symbols have been used in that first line to get to the second line, and this minus is in the middle there by itself. It's not inside one of those, so it's just a normal minus. All right, now we can put them on number lines. We can illustrate. So here, let's have a look. So the first one here, the modulus of x is less than 4. All right, so for A, what does it mean? So we've got modulus of x is less than 4. So what we mean means the size is 0 to 4, between 0 and 4. All right, because remember the modulus makes get rid of the negatives, so we're not going lower than 0 because we don't want those. the modulus. So the size of it is between 0 and 4. Well, that's pretty simple and straightforward. If you've just got, and it's less than, so open circle, and it's down here. But if I take the number, say, -2, for example, as x, so for x equals -2, what we're doing is then we've got to take the modulus of -2, which is 2. So in actual fact, these numbers here, between -4 and 0, also fit into this, because their size is also between 0 and 4. All right, the next one, related to, so B, we've got the magnitude of x is greater than or equal to 4. So we're wanting something that's going to be bigger or equal to 4. 0 there, the size of it, so there's 4. Now this is equal, easy enough. Numbers 5, 6 and so on, all these ones up here are bigger than 4. But if we also think about it at -4, when we take the modulus of -4, of course that's 4. And down here, say at -6, the modulus of -6 is 6. And that's bigger than 4. So we're also, in this case, wanting these numbers down that way as well. All right, so, I forgot the second part, and it says write in interval notation. All right, so the interval notation, let me just change my, change my color here to orange. So the interval notation of this first one is simply -4 to 4. The interval notation for the second one, because we've got two parts, one of the parts, again, remember we start at the smallest number, so we're starting down here at -infinity. Convention, curve bracket, and we're going up to -4, which we're including. Then we want to start again at 4 and go up to infinity. And because we want both of those, we use the u in the middle there. All right, the next one, the magnitude of x -1 is less than or equal to 4. So let me go down here. So I'll rewrite that. See, the magnitude of x -1 is less than or equal to 4. All right, so that's quite interesting. So let's have a look. What could this in here be? So the step before we take the modulus, this number here could have been, this number here, it could have been +4, or it could have been -4, and then we take the modulus of those. So this x -1 bit, it could, and I'm just going to look at, let's just look first of all where it equals. So let's first of all just look at x -1, where it equals 4. That gives us a starting point, and then we can go from there. So let's go, all right, x -1, it could be the +4, and then if we add 1 to both sides, x would be 5. But it could, the x -1 part could come out to be -4. And then, of course, when you use our modulus signs, it becomes the 4. Okay, so add 1 again. So in this case, x is -3. So when we're putting on our number line, -3 and 5, because it's equals, those points are included. Now, the question is here, it's less than. All right, so it's less than or equal to 4. So if x was, say, 0, for example, 0 - 1 is -1. So let's try x equals 0. So when we do that, magnitude of 0 minus 1 is the magnitude or the absolute value of minus 1, which is 1, and that is less than 4. So this 0 here is what we're looking for. So 0 is what we're looking for. So that means that all of those, if we tested any of those, they'd be what we'd be looking for as well. All right, so our interval notation on that, where are we? Change the colour. Do the interval notation in orange, and the interval notation, we're starting at -3, which is included, and we're going up to 5, which is also included. All right, now the next thing, we can draw graphs of these. So y equals x, magnitude of x. So this what we've got here is y equals x. All right, so the thing is though, for the magnitude of y equals x, so down here in y equals x, these ones down here, this bit down here, they're all negative values. And these x's here are all negative values. But for, excuse me, for y equals the magnitude of x, the size is positive. Right? So effectively, this bit here, so this part, gets reflected in the x-axis. All right, so here, for example, that's x equals minus 5, but because we're looking at magnitude of x, we ignore magnitude of minus 5, and we ignore the negative, and it's 5. So there, the point goes to here. So that gets reflected, and we end up going up there like that. So here, I'll redraw. First part stays where it is, but the other part goes up here. And so this one then is y equals the magnitude of x. All right, and as you can see, it's symmetric about the y-axis. So if we reflect it in the y-axis, we have the same thing. Just a note, another way that we can write this, magnitude of x can be written and this is what we would call a piecewise function. So we split it up into pieces. So when x is greater than or equal to 0, we just take that number. And effectively what we have when x is less than 0, we have another negative in there. And so if you drew the graph of y equals negative x, of course, it would be this part here. All right, so the negative of negative, so here when x is, I'll use -5, then y is the negative of -5, which is +5, and there's that point there. All right, and we can do what it says here. We can, at the bottom it says the graph can be translated, reflected in the same way as other graphs. So probably not done too much of that yet. So let's have a look. I've got the calculator here. So here's the calculator. I've put some things in there. So let's, and I'll show you here with number 6 where you find those symbols. So there it is. All right. So we're going to compare all these others to this one to see what happens, whether it moves or whatever. All right, so if we added +2 on the end, Here we are. It's up here. So it looks like it's up 2. If we had -1 on the end, yeah, it's moved down. All right. So let me get rid of those 2. And then, so instead of having a number outside, so we put it inside. Let's have a look and see what happens there. All right, +3, it's down here at x equals -3. -3 plus 3 is 0, of course. And here, let's add this one. Over here at 4. So when it's inside, it moves it left or right. When it's outside, it moves it up or down. And then you probably can have a combination of those things as well. Again, incidentally, x equals 4, 4 minus 4, 0. All right, so I said I'd show you how to use that. So if you go to your keyboard, this symbol here, magnitude, and I'll go, let's go x minus 1, and let me then move outside. So I use this, move outside, +2. And let's now turn our keyboard off, and now let's graph that. There it is here. It's moved, so it's at, so instead of that point, it's now here. Instead of being at 0, 0, it's now at 1 and 2. All right. So that was one thing. Now there's another bit that we can look at. What if we have a minus out the front of the modulus sign? Let's go to the keyboard. I'm going to have minus. So for the negatives at front, I always use this one in brackets. So minus magnitude of, let's go x minus 2, and then let's go +3. Turn that one off. Let's now graph. Boom. There we go. So this negative here looks like we've flipped it over. So it's been reflected in some horizontal line. Our point that we're looking at, excuse me, 2 and 3. So it's what is the opposite to here? It's the opposite because we're looking at the x value that makes inside here equal to 0. And the x value that makes that in there equal 0 is 2. 2 minus 2 plus 3. Start here, it's upside down. Always has a gradient of 1. So if I go back to the notes here, I've summarised that. So it can be translated, so that's the moving left, right, up or down, or reflected in the same way as other graphs. And so if we put it in this form here, y equals plus or minus the magnitude of x minus h plus k. If it's a negative, we've got a reflection in a horizontal line, translation left or right in here, translation up or down here, and the point, and when I say the point, that's this point down here, that we're starting point, is at h and k. Okay, so let's have a look at sketching. It says, sketch each of the following and state the range. All right, so here's another definition for you. So the domain is the x, and we'll be doing this more, you'll be doing this in methods and in special, these terms, domain and range. But basically, the domain is just the x values that correspond to our graph, and our range is the y values that correspond to the graph. And so we're looking at the ranges. Okay, so here we go. We've got the magnitude of x minus 3. So from what we said before, is that we're going to have a translation, and it's to the x that makes that bracket equal 0. So we're going to have our translation to the right 3. That's for that one. And for this one here, that one is a translation up 1. All right, so that key point that we were talking about, so the key point be at 3 and 1. All right, so if I draw a graph, here's my graph, 3 and 1. So there's the key point of 3 and 1. And gradient of 1 goes like that. And we could find out this the y-intercept, because y-intercept, as always, is when x equals 0. It's the magnitude of -3 plus 1. 3 plus 1 is 4. All right, now the range, so the y values. So the y values that correspond, so the graph's is up here, above this line here. So our range then is y's, our range is y greater than or equal to 1, or if you like, 1 to infinity. All right, so it just corresponds to the y values here that correspond to where this graph is. All right, the next one. So you can see here we've got a reflection with the negative out the front. Same idea with these two numbers. Translations, the one in the bracket, x is -2 to make that equal 0, so -2. Ooh, nearly missed out on that, and then 2 down as well. So that's our key point. So let's have a little bit of a y and x. So -2, -2. So here's our key point. Reflection, so it's going upside down. And this point there would be when x equals 0. So y equals the negative of 0 plus 2 minus 2, the negative of magnitude of 2, which is -2 minus 2. All right, so this negative here, because it's outside, nothing happens to it. And that equals -4, of course. All right, so there's some sketches there. All right, so that's modulus or absolute value. I often use the word magnitude, as you've probably heard. That's kind of in a nutshell. There's a bit more stuff that can kind of happen, but with it, but we're just sticking to that y equals x graph for the month for this year. All right, it's more to do the concept that what these two lines here, what these two lines mean. Okay, that we're just looking at how big something is. All right, as always, have fun.